Okay. All right. Homework 2 today. That's that worksheet 2-1, part 1, or 2-2, I think, part 1. It was on solving equations. That was due today. So make sure you're working on that. Make sure you get it turned in. That's the first assignment on the next quarter grade. So quarter 2. We're going to look at probably the second part of it today. We're going to really kind of start that process. So if you have notes, it'd be a smart thing. If you have your property sheet, that'd be a smart thing to have out right now. I got 2 problems I'd like to go over. 2. And then we're going to kind of mix it together and we'll kind of see if you need a third one. So I'm going to put these examples back on the board. They're very similar to what we did yesterday. Let's go with 3m plus 4 minus, go with 2x plus 7 plus 9m. That should be our first example here. Goal is to go through 2 of these, 2 problems. If we need a third, we'll do a third. Okay, there's what we're doing on this second part of this this unit we're in section 2.2. We're looking at solving equations and expressions, and today's stuff is the expression part. So we're going to be trying to simplify this as far as we can. We did a couple of these yesterday. We introduced it. So if you were gone yesterday, you probably missed just the first chunk of it, the first piece. How many steps does it take to simplify an expression? 3. Yep. So to simplify an expression, there's 2 types of expressions. You're seeing the first one, where you have to just combine like terms. It takes you 3 steps. So every single type of expression takes 3 steps. Now, where it could take more is if they mix 2 types of problems together, where they take something where you have to combine like terms, and maybe in the middle of that problem they throw a parenthesis where you have to do the distribution stuff. So that could take more. Another chance where it could take more steps, if they don't have numbers in front of your variables, and you have to introduce like the number 1, like you have to introduce it right at the first step. That would be a multiplicative identity, where you have to multiply by 1 so that there's a number in front of n before you even start the problem, or an x or whatever variable you have. So if we need to do one, maybe I'll show that in the next part. Okay, so here's our first example. What do we need to combine on this problem? Like terms. What are my like terms? You're right.
3, 9, 4, and 7.
Yeah, 3 and the 9 because they have the m's on them, right? So you can move them wherever you want. So if you want to move the m's out front, so be it. If you want to put the m's in the back, cool. You can put them anywhere you want. I don't have a specific spot where they need to sit. You just need to realize those are the 2 you need to put together. I agree with the 4 and 7 route because those don't even have letters on them. So at some point I have to combine those. And then that negative 2x will just hang out by itself. There's really nothing you can do with it. And I don't care the order you put them. It doesn't matter, as long as you're grouping. Now, what property is this where I move things around? Commutative. That was that property we discussed yesterday. Commutative means to group and move. So on your little property sheet, if you have not written the commutative step where it's group and move, then you probably want to put those little notes off to the side. So it's commutative. That's usually the first step when you want to combine like terms. Pretty straightforward. Okay, now, next step. What do we do?
So you're going to do the problems.
Okay, now we have to try to combine them, right? The difficult part, and this is the part that most people don't realize, when you try to add the m's together, you have to factor the m off of them. Because technically you are trying to add the 3 and 9 together. Well, they can't see each other. So you need to write it like this, where you factor the m off of them. You're just pulling the m label off into the back. And you're showing that I'm going to add the 3 and the 9 next. Or maybe you'll subtract, I don't know, whatever numbers you have. And then back here, same thing, I'm just going to leave these alone. And then that 2x back here, leave that alone. If there's more than one variable, cool, just do the same steps. That rule, that property that we just discussed there, that is called reverse distribution. Reverse distribute. Or it's called factoring. That's the term I like to use because that's what they use in all other textbooks. It's called factoring. Okay, questions with what I did there? so that numbers can see each other. You grouped them, now the numbers need to be put right side by side so there's nothing in the way. Now I can do the math. So, what do we have? We have 3 plus 9, which is 12, M. 4 plus 7, 11. We have that 2x. I forgot the x on that. Where did the x go? Just forgot that earlier. Got the 2x. All right. That step where you just combine, you added, subtracted, you multiply, divided, just random digits together, that's substitution. Substitution. All right. Questions? Okay, that's the first type of problem. 3 steps every single time. Pretty straightforward. All right, let's go to the second problem. This is the last one I want to cover. We can pick really anything we want. Let's go with 5. Let's go with 8. Okay, 8 minus 3x plus 2y or 2y. We can go 10y, doesn't matter. Let's do that. Okay, I can pick any other letters I want. I'll do the problem here in a minute. So these are get back. All right. This is the other type of expression that we have. It's when you have to distribute. It's when there's a parenthesis and there's something you're going to multiply through. On the inside, if there's anything that I can combine like terms, you'll do that later. You just want to do the normal distribution step first. Don't make it harder or longer in the beginning of the problem. You just want to try to distribute first. Hi, welcome. How'd the tapping go?
Okay, there's a lot of people.
Was there? Yeah, good. So, all right, but welcome. We're just doing a couple examples right now. So the expressions we started yesterday, so really similar. This was the first one we just did, where we talked about it takes 3 steps to do these. You have to move them around, kind of group up like terms, that's commutative. You have to pull off the letter if there's letters that you have to add together. That's called reverse distribution or factoring. And then we combine them using substitution. So, okay, for those walking in, we're on the second problem now. Okay, we need to distribute on this particular problem. You get my email?
Well, I figured it out after Eric and I
Okay.
tried for 20 minutes.
It was the problem we talked about in class yesterday. We used
Yeah, I
quadratic.
forgot about that. And then can I talk to you for a second when you're done?
Yeah. What's up?
I don't know. I was thinking about Shelby ran in and show me how Kennedy how Hannah, not Stephanie Meyer, Ashton, both Franks, Isaac Newton, there's a lot. There's at least like 50 people on that stage. Yeah. We had to FaceTime Shelby Brady because she's at her cattle show.
All right. So let's go through this second problem, I should say. Okay, we need to distribute first. We're going to hand out this 5 to everything here. So we're going to hand the 5 out to the 8, hand the 5 to the 3, and hand the 5 to the 2. Okay, so that's the first step. When you have a problem like this where there's a number on the outside and it's physically attached, it's being multiplied, it's not being like added out front or anything like that. We're going to multiply this through. Now, the step that we have to do, the first step, you have to hand it out. You don't actually just multiply. Don't write 40 and 15 and 10. You're skipping too many steps. What we want to do is hand the 5 to each item first, like this. Ooh, I have to write the 5. 5, we're going to hand it to the 3x, and then the 5, hand it to the 2y. Okay. All right, So we've handed it out. Now that property where you've actually handed out items to other items, that's called distribution. That's normal distribution. It's not reverse. You're actually handing items out into a parenthesis. It's distributive. It's that 6 property. So that's distribution. This is a little bit different, what we did earlier. This, when you're trying to combine M's and you're taking the label off, the M, you're actually ripping it off the back. That's factoring. It's reverse distribution. You're going back out of the parenthesis. I'm going into the parenthesis. So that's just normal distribution. Now, the second step, and this is maybe something you need to have on your property sheet and you make that little note. Like yesterday we talked about, commutative, making that little note that says group and move. The next little note you need to make to yourself, I don't know if you have already, every time you do distribution, that 6 property, the next property that comes after it has to be associative. So maybe you need to draw an arrow on your paper where you go from distributive, that's the 6 property, and you always go to the associative step. I don't know, what is that, the 3rd step? Yeah, your 3rd property. You always have to follow it with associative. The reason being is that these numbers can't see each other. They honestly don't see each other. So there's the bars are in the way. So we have to move the bars, and that's associative. It's moving parentheses. I think that was one of the little notes I had you write on your property sheet. You had to write parentheses. So I'm going to move the bar. So 5 times 8 can actually see each other now. The 5 times 3 can actually see each other, and the x is outside, right? You're just grouping the number. And then the 5 times 2. I'm not moving the numbers around. The numbers didn't move, so it's not commutative. I'm just moving the bars, the parenthesis bars. So that's why it's associative. All right, so that is the associative property. It always follows distribution. It's 100%. I've always said that. If it's normal distribution, not this weird factoring stuff. Okay, now at the very end, now you can start doing the math. So 5 times 8, 40. 5 times 3, 15. And 5 times 2, 10. And that's substitution. Typically, substitution is always the last step, if you haven't noticed on all of your problems, because it's called the closure step. It's the closing argument. It's like what you're trying to get to. It's what everyone always just thinks the answer. They just know the answer, right? You know what the final answer should be. You can do it in the first few seconds. We're trying to show how you get to that point. And that's always tough. It's trying to come up with arguments, trying to come up with reasoning that's logical. It's actually using, facts, rules, definitions, properties, all that good stuff. All right. Questions so far on this problem? Okay, those are the 2 I want to get through. Those are the 2. This is exactly what expressions look like. They're not equations. We don't use any properties of equality. We don't do that 4-step method we did yesterday, where you had property of equality, inverse, identity, sub. We don't do that. The reason being is that we're not solving. We're not trying to get m or find what x is. You can only go so far. So it's typically always a 3-step process. Now I've hinted at you could have more. If one of your letters was missing a number out front. So I'm not going to do an extra problem. I just want you to see this. If your problem started like this, maybe this is your problem. That takes 1 extra line of work. It takes 1 extra property. You can start right off the bat. If this is printed on your worksheet that we have, just put a 1 there. You need to have a number in front of every variable. So by just multiplying by a 1 out front, that's the multiplicative identity. Multi-identity is when you multiply by 1. You can introduce the number 1 in front of a letter, because every variable should have a 1. Because that property works. You can multiply by 1, it's still the same variable. That might have to be your first step. Then you'll take 3 steps and you'll do these. You'll do those 3 steps to combine like terms. You'll move things around, move the x's next to each other, factor the x off, or reverse distribute, however you want to say it, and then substitute and figure out that it's 3x plus 5 in the very end. Does that make sense, like the concept that we do there? Or maybe your problem looks like this. maybe this is your problem. That problem will take more steps. In fact, that problem will take you 6 lines of work. Why it takes you 6 lines? It will take you 3 lines of work to do this distribution stuff. It's an expression. You have to do the parentheses first,
Okay,
and
the 7,
then the last step is then you'll have to add the 7 on.
7 has to come into play.
Yeah, that'll come at the very end. So you'll do 3 steps to get, do the distribution stuff. You'll do that. You'll distribute, you'll associate, you'll do a substitution. So you'll eventually get down to this. Oop, that should be a 15. You'll eventually get to this after you do your 3 steps of distribution.
Yeah,
Then
negative.
you have to do these 3 steps where you have to move them around, factor it out, or reverse distribute, and then sub. So it's always the same. It's just what do you need to do first? Now again, these are expressions. So the thing I'm really kind of hinting at is that you're doing this acronym again. If you haven't noticed that. We're back to the normal PEMDAS acronym. It doesn't have an equal sign. Equal signs you do SADMEP, you go backwards. But on expressions, you have to do the parentheses first. That forces you to actually multiply first to do the parentheses. Then when you do that, then you can add and subtract last. So that's the big thing, is understanding like what order you need to go in. There's some goofy things I see from year to year when we get to these problems that people do. Like for instance, one of the goofiest things I've ever seen somebody attempt is something like this. I'm gonna put that problem back up here on the board. That one, right? Shouldn't have erased it. I've seen goofy answers where people, like, when they first start the problem, they're like, oh, I'm going to combine the 7x and 2x to make 9x. And then they're going to distribute 5 over it. No. No. You went out of order big time. You made colossal mistakes there. Yeah, we'll eventually have to add the 7x, but you have to follow the order of operations. Parentheses first. Then after you finish the parentheses, then add and subtract last. So just make sure that you are taking your time. If you know that your problem has something like this, maybe this is what your problem eventually turns into. And so these ended up being 0 in the back when you combine like terms. Like you did all this, you substituted in the back, and it turned out to be 0. That's not substitution. This step isn't substituting. That's property of opposites. You just made 0. You added or subtracted 2 numbers to make 0. That's property of opposites. Then you have to add the 0 to use added identity. So I've seen that before I think in some of the Algebra 1 courses that we have here, Algebra 1A, Algebra 1B. I've seen problems on those written tests that look like that, where they had you actually like subtract and then add the 0. Typically my problems look like this, where they're pretty basic, but I've definitely seen weird ones where you actually have to do those weird properties we haven't seen. All right, questions on your properties? Okay, I'm gonna hand out your worksheet. Now the worksheet is gonna be due next week. It's the one assignment we have today. It's due, I think it's due like Tuesday next week. It's based on expressions only. It's 5 problems based on expressions. It's part 2. This is the last part of all of our algebra stuff before we go into graphing.
I have a question about this property.
Okay. Okay, so again, these problems, if you look at the expressions, they'll typically take 3 lines of work. Where you might need an extra line of work is if you have to introduce a number 1 in front of something. This will be due on Tuesday next week. So just make sure you are showing the work, you're writing the property steps down. I've left my 2 problems on the board so you can kind of see how I did mine. There is a problem or 2 on there where you have to go more steps because I combined the 2 problems together. You have to like distribute first, do those 3, then you might have to combine like terms at the very end and do those 3. So just be careful. I think I gave you enough space, I think, to do them. So just be careful. Okay. No, you're taking 10 times the negative, so that should be a negative number still. Should be a negative. Yeah, you just leave the negative sign right there. Okay. All right. Turn off the camera here. You guys can just kind of work. You got about 15, 20 minutes here.